Today we're in section 5.4, multiplying fractions. Multiplying fractions, textbook page 237. You don't need to write this first slide, but I do want to go over just a few things. Basically, the definition or the description to multiply fractions says this: the product of two or more fractions is equal to the product of the numerators over the product of the denominators. Simply put, you multiply the numerators together and you multiply the denominators together to get your answer. 3 times 4 is 12 and 5 times 7 is 35. All right, now you can do the same thing with variables. A times C is AC and B times D is BD. They're just showing you that you multiply numerators and you multiply denominators to get your answer. Really, guys, the only place you can go wrong here is you could forget and try to cross multiply, but we don't cross multiply, we cross reduce. Okay, we'll talk more about that here in just a second in example 1. So go ahead and write this fraction down. 7 over 10 times negative 4 over 21. What we're going to do is we're going to look for an opportunity to cross reduce the numerator and the denominator by the same factor, okay? So same thing with negative 4 and 10. So can I reduce 7 and 21 by the same factor?
Yes.
What would it be? 7. I would reduce 7 by itself, 7 to get 1 and 3. All right, can I reduce 4 and 10? By what factor? 2. Okay, so now 4, watch this though, we have to keep the negative. All right, if you keep the negative when you reduce, you're much less likely to forget it, okay? And it's just easier to go ahead and attach the negative with your numerator. Technically, it doesn't matter, but because either way, you know, you still have the negative in there, but if we could just all attach it with the numerator, it makes it a little easier. All right, and then 10 reduces to 5. So now I have actually reduced every number involved in this expression. Now I'm going to go ahead and multiply my reduced factors. 1 times negative 2 is negative 2 over 15. And if I have effectively cross-reduced, then the first time I multiply will be my final answer. It will not be able to be reduced anymore. Now, this is an important step to your homework tonight. I must see cross-reducing where it is applicable, because it goes back to what we talked about yesterday. If you don't show me cross-reducing, how do I know that you just didn't put it in your calculator and write the answer? I have had a struggle with a few papers today where all they had was answers and they did not show LCD. And it's just like what I said yesterday. I can't give you credit because there's no proof that you actually did the work, okay? So the cross-reducing is the proof that I need, okay? Does that make sense, guys? All right, so let's go ahead and look at the next one. All right, can we cross-reduce anything on number 2? 5 and 10. I can reduce by 5, so that becomes a 1. This becomes a 2, and we get 7 over 16. 7 over 16. All right, on the next one, go ahead and do that one on your own. Cross-reduce anything?
Yes.
Yeah, 2 and 6, down to 1 and 3, and it just becomes 5 over 9. All right? Okay, good. Who got it right? 5 over 9. Who got it right? Okay, now in example 2. Okay, in example 2, I'm multiplying a mixed number in an integer. What's an integer?
A whole number.
It's not necessarily a whole number. It's a number because, I mean, it can be negative. Negative numbers aren't whole. But it is a number that does not have a decimal value. So it is negative 3, negative 6, 5, 8. Okay? It's just the number. It doesn't have any decimals or anything like that. All right, so each year the Academy of Television Arts and Sciences presents gold-plated Emmy Awards for programs and individuals in the television industry. Each Emmy statue weighs 4 3/4 pounds. It's pretty heavy. In 2002, 63 statues were awarded. So what was the combined weight of all the statues? If you know how much one weighs, you can multiply that by the total number of statues that were awarded to find your total. So we have 63 times 4 3/4. What did we talk about in the last section? What we need to do anytime we see mixed numbers. So go ahead and change both of these fractions or both of these numbers to improper fractions. 63 over 1 and 19 over 4. Is there anything we can cross reduce? No, so we just multiply it. All right, now that's a pretty big number, okay, but that's all right. Now I need to switch it over to a mixed number. I can use my calculator at this point to make the conversion, or I can divide it by 4 to get my whole number, and then subtract that total to find my leftovers. All right, and it's going to be 299 and 1/4 pounds. Okay, and we can leave it a fraction. That makes sense since our original numbers were in fraction form. So that would be how I would do that. Okay, so we're going to do the top two now, multiplying a mixed number and an integer. So again, you're changing them both to improper fractions, cross-reduce where you can, and just make sure your answer is now converted back into a mixed number. Okay, 4 5/6 is 29 over 6 and 7 over 1. Nothing can be cross-reduced, so we get 203 over 6. All right, then we change it back to a mixed number. Who got 33 5/6?
Oh, that's me.
Okay, all right, finish up the second one. 6, I just make 6 over 1, and then negative 39 over 7. Now, nothing to cross-reduce. Keep your negative so you don't forget about the negative. 33 3/7. Who got it right? Okay. All right, just don't forget about that negative. Okay, moving on to example 3. Now we just are multiplying two mixed numbers. So there's really not a whole lot of difference between examples 2 and 3, except now it's just two mixed numbers that I have to convert to an improper fraction. So we're only going to do one of these since it's so similar to example 2. But I do want you to go ahead and do the first one, negative 2 3/4 times 3 1/5. I must see the conversion on your homework assignment tonight. I need to see improper fractions and any cross-reducing that might be available. Okay, so it's going to be a negative 11 over 4 and 16 over 5. Can I cross-reduce anything? Okay, you need to take advantage of any cross-reducing. All right, reduce that to 1 and 4. Negative 11 times 4 is negative 44 over 5, and I convert that back to a mixed number. You can use your calculators, or that's one that you may be able to do mental math. Okay? All right, so that's it for example 3. All right, so now in example 4, this is where we're going to make a tie-in with the variables to simplify expressions. All right, now, this is like what we were talking about before we started the lesson with our product of powers. If it's the same variable base, I can add the exponents together. I still need to cross-reduce any coefficients where possible. So in the first one, is there any cross-reducing that I can do?
No.
Yes, there is. 3 and negative 12, which becomes 1 and negative 4. Again, when you cross-reduce a negative, keep it negative, and that will help you to not forget about the negative. It's a very easy mistake to make. So now I can multiply. How would I multiply negative 4 times m? What would that be? Just negative 4m over 5. Is this a proper fraction? Yes, it is. 4 is smaller than 5. That's fine. Okay, so we're done. All right, so negative 4m over 5. I had another question earlier. It was a good question. They said, where does the variable belong in our answer? And it's probably the easiest answer to that is wherever it began. So if it began in the numerator, it needs to be in the numerator in our answer. If it began in the denominator, it needs to be in the denominator, if that makes sense. Okay, so go ahead and do the second and third one. Go ahead and do the second and third one. Try to cross-reduce if you can, and then we're going to use product of powers to add any exponents of variables. All right, so is there anything I can cross reduce?
5 and 10.
5 and 10, okay, so 5 and 10 cross reduce, we're not talking. All right, now when I multiply my numerators, what would be n squared times 1n to the third?
1n to the
1n to the fifth, or I could just say n to the fifth, right? I don't need the 1, it's understood. All right, and then on the bottom, what's 2 times 9?
18.
18. All right, who got that right? Good, good. Finish up the third one. Okay, so we cross reduce again on the third. Remember, you're cross reducing at any opportunity. 1 times 3a to the third is 3a to the, or I'm sorry, 1a is 3a to the fourth. Did you get 3a to the fourth? Did you remember the a by itself? And then 7 times 2 is 14. All right, who got that one right? Okay. 1 times 3 is 3.
Oh, yeah.
Okay, and then you can't forget about the other A. I want to do 2 more of these. I just feel like this is probably the one example in the lesson that's just kind of new, so I just want to do a little bit more practice with you guys. Go ahead and do these 2 problems. We'll go over them in just a minute. All right, so 3y and over 4 times y to the 5th over 9. Anything we can cross reduce? 3 and 9, okay. And then I have y to the 6th over 12. Who got it? Y to the 6th over 12. Did you forget? Hopefully you remember that this first y has an exponent of 1, so 1 plus 5 is 6. Y to the 6th over 12. On the second one, I can cross reduce again. Don't forget that the 8 is negative, okay? So negative 8x to the 5th over 9. It's going to be my answer. All right? And if you understand that, what is it, guys?
That's everything you need to do for 5.4.
Yes, for 5.4. There we go.